Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 2 paper from summer 2022. This paper is worth 120 marks in total, and this is the fifth video of 6. It will focus on questions 18 to 21, which account for 18 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 18. At a hotel, 70 guests completed a feedback survey. The survey had 3 statements A, B and C. Guests could tick 0, 1, 2 or all 3 of these statements. The Venn diagram shows the number of the 70 guests who ticked each statement. So this is our Venn diagram. Part A, one of the guests is chosen at random. Find the probability that this guest ticked statement A or statement C, but not statement B. So A or C, but not B. Okay, so what we're interested in is anyone within the A circle and the C circle, but we're not interested in anything that overlaps with B. So the only values we're interested in here are the 16 that chose A, the 17 that chose C. Okay, guys, the rest of them here, the 6 and the 13, also chose B, so we're not counting those. So we have 16 plus 17, which is 33. We have 70 guests in total, so it's 33 out of 70 as a probability. Part B, given that a guest ticked at least one statement, find the probability this guest ticked statement B. Okay, so if they ticked at least one statement, they must appear inside these circles. So we are not interested in these guys here because they didn't pick a statement. So out of the 70 people, 6 didn't pick a statement. So we're working with 64 people in total here. So we're going to put 64 on the bottom of our fraction for probability. Okay, we want now the probability that this guest ticked statement B. Okay, so we're interested in everything in the statement B circle. So 6 plus 12 plus 13 is 31. So it's a probability of 31 out of 64. Question 19. Find the equation of the line parallel to 4x equals 5 minus y that passes through the point 1 minus 1. Give your answer in the form y equals mx plus c. Okay, so for lines to be parallel, they have the same gradient. So we need to find the gradient of this line, so then we'll know the gradient of the line that's parallel to it and passes through it. So to read off the gradient, it's easier if we're in the form y equals mx plus c. So currently this equation isn't. So I'm going to rearrange that to be y equals mx plus c. So the first thing I'm going to do is add y to both sides because I don't want a negative y, guys. So 4x plus y equals, and then when I add y here, it eliminates it and just leaves me with 5. Now I'm going to subtract 4x. So y equals 5, subtract 4x. Now it's in the form y equals mx plus c because the x term with the gradient and the y-intercepts on the right-hand side. So I can see that the gradient here is negative 4. Remember, it's the m value, the coefficient of the x. The gradient is negative 4. So the gradient of the line that's parallel must also be negative 4. We just don't know what that y-intercept is. But they do tell us that it passes through the point 1, 1. So we can substitute those x and y values in and solve for c. So y is negative 1, x is 1. So that's negative 4 multiplied by 1 plus c. So negative 1 equals negative 4 plus c. So c is equal to negative 1 plus 4. So c is equal to 3. So our equation is y equals minus 4x plus 3. Part B, find the equation of the line perpendicular to y equals 1 minus x over 5, which passes through the point 0, 7. Okay, so perpendicular lines have the negative reciprocal gradient. Okay, so we need to find the gradient of this line. Now it is in the form y equals mx plus c. So in this line, the gradient is negative 1/5. Okay, so it's negative 1 over 5x. So if the gradient is negative 1/5, the new gradient of the perpendicular line is the negative reciprocal of this. So instead, we're going to change the sign, so it's going to become positive, and the reciprocal of 1/5 is 5. So the new gradient of the perpendicular line is 5. So we will have y equals 5x plus c. We need to find out the plus c, we need to find out the y-intercept. So we're going to use the x and y values of the point that it passes through. So when x is 0, y is 7. So c must equal 7. So we have y equals 5x plus 7 as our equation. Is 50k multiplied by 1 minus 50 over 100. Well, 50 over 100 is a half. So this is 50k multiplied by 1 minus a half, which is a half. So 0.02 equals 50k multiplied by a half, which is 25k. So k is equal to 0.02 divided by 25. Okay, so that gives me a really small number, so I'm going to keep it as 1 over 1250. Okay, so I'm going to substitute this k value into my formula. So r equals p over 1250, because it's k times p, multiplied by 1 minus p over 100, all together like that. Part B, find the positive value for p for which r is 0. Okay, so we're going to use this formula here, and we're going to set it to r equals 0. So 0 equals p over 1250 multiplied by 1 minus p over 100. So let's expand this bracket. So 0 equals p over 1250 multiplied by 1 is p over 1250. P over 1250 multiplied by minus p over 100, well, that's going to become a negative p squared over 125,000 either. So 1250 multiplied by 100. Let me check that. Yeah, that's right. Okay, so now what we want to do is, if we make these as fractions over the same denominator, we can work with it easy enough. So I'm going to multiply this fraction by 100 also. So 0 equals 100p over 125,000 minus p squared over 125,000. So when I multiply by 125,000, I get left with 0 equals 100p minus p squared, because 0 times by 125,000 to get rid of that fraction is 0. So then we've got a quadratic equation here, guys, okay, that we can solve to find p, and we want the positive value for p. So what I'm going to do is I'm just going to rearrange this equation. So I'm going to add p squared, subtract 100p is equal to 0. So then I'm going to factorise here, guys, for p. So p and then p minus 100 equals 0. So we have a solution of p equals 0, and we have a solution of p minus 100 equals 0, so p must be equal to 100. We want the positive solution, so this is the solution that I am interested in. Question 21. There are 8 seats in the front row of a theatre. 8 friends sit down in this row. Part A. When each friend can sit in any of the 8 seats, find the number of different seating arrangements possible. So if there's no conditions to which seat they sit in, we're going to do 8 factorial. So we're going to do 8 multiplied by 7, multiplied by 6, by 5, by 4, by 3, by 2, and then by 1. Because the first person has 8 seats to choose from, then they'll sit down, which means the second person has 7 seats to choose from. Then the next 6 seats, 5 seats, and so on. So we're going to do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 40,320. So that's how many different arrangements are possible. Part B. Liesa and Todd are 2 of the 8 friends. Find the probability that Liesa is sitting in the first seat on the left and Todd is sitting next to her. Okay? So, the probability that Liesa is sitting in the first seat, so that is a 1 out of 8 probability. And then the probability that Todd is sitting in the seat next to her would be a 1 out of 7 probability. Okay? So it would be 1 over 1/8 times 1/7, which is 1 over 56. Okay?